and the Q&A. So please make sure that your chat or your Q&A questions are addressed to all panelists or everyone, just because I won't be able to respond during the presentation. So welcome everybody. My name is Conleigh Bauer. I am the Architectural and Design Rep for WRmeadows of Texas. So I cover the Texas region, Arkansas, Oklahoma, and Louisiana. And today we're going to be discussing blindside waterproofing, how it differs from traditional waterproofing, and different materials and methods we can use to make these systems successful. But before we get into the content of the presentation, a little bit of background on WRmeadows. So we were established in 1926 in Elgin, Illinois. Our headquarters has now moved to Hampshire, Illinois. But 95 years later, we are still family owned and operated by the Meadows family. We have 12 manufacturing facilities in North America. 3 of those are in Canada, and we have a couple warehouses spread out throughout the United States as well. So not every product is manufactured at every plant. We have over 300 products, maybe even over 350. But because we have such a wide footprint, we're able to use our facilities as a distribution network, and we're able to get you the products you need when you need it for your projects. Back in 1926, we started off with asphaltic expansion joint material. We still produce joint material today, expansion joint material today, but we have expanded our portfolio to quite a few other products. We have a great concrete restoration line, construction liquids, which include curing compounds, sealers, densifiers, joint sealants. We have a relatively new joint sealant production plant in Fort Worth, Texas, that opened a few years ago. We have a decorative concrete line, and then building envelope, which is what we're discussing today. This is where I spend a majority of my time working with architects in design stages, discussing their waterproofing system, air barrier system, and their below grade vapor retarders. We also have a sister company, Blue Ridge Fiberboard, and they do soundproofing and insulation. Like Roger said, this is an AIA presentation. You will all be receiving certificates sent to the email address you provided. If you provided your AIA number, we will be submitting those credits directly to AIA. This is also approved for health, safety, and welfare credit as well. All right, jumping into the meat of it. Today we're talking about blindside waterproofing. We'll start off with some fundamentals of below grade waterproofing, why we care, what are the types available, materials available to us, what are different strategies, and then moving in specifically to blindside, why would we choose this option over a traditional blindside or a traditional waterproofing method, excuse me. Which site conditions require blindside application? We'll go into the common material types, pros and cons for each, and then the installation techniques to install each of these types of materials. Oh, come on, click. Go. Okay, basics of structural waterproofing. Why do we care? Why are we waterproofing our structures at all? Well, obviously it's to prevent liquid water from entering the structure. Without a waterproofing system, liquid water is able to seep its way through the concrete through capillary action. So concrete is an incredible material. It's very strong, but it's very porous. It acts as a sponge and a reservoir to hold liquid water and move liquid water into the interior. So it's not waterproof on its own. Water can also move through the cracks in the concrete. Again, concrete is a fantastic material, but it's not will it crack, it's when is it going to crack and where is it going to crack. We need to anticipate the concrete cracking and design around that. Excessive moisture can cause damage to the structure itself. So liquid water can enter through the foundation wall, through the slab, and corrode the materials, corrode the rebar, and we're trying to combat against rainwater that can saturate the soil, irrigation system runoff, drainage from the surrounding sites, groundwater, the water table, all of these different sources of water. And the water table can change during the year. You know, it's typically lowest or highest in the spring and lowest in the fall. And anticipating where this water is going to come from and how much protection we need for our systems. Having unwanted moisture in the interior can also lead to health concerns, the health and safety of our occupants. We want to make sure to keep any unwanted organic growth like mold or mildew out of our structures. And then obviously, if we have liquid water coming into the interior, that is not an occupiable space for the people using the space. Our water control system is more than just the membrane. So water control is going to be addressed on all 6 sides of the building, and what we're doing above grade will contribute to how effective our below grade systems are. So the first line of defense is deflection. We want to deflect water away from the building as quickly as possible, and this can be the use of overhangs or gutters, or even grading the soil so it surface water flows away from the structure. That's all going to help deflect water away. Now, the water that gets through our deflection system, we need to protect our structure, protect our concrete. Above grade, or our sheathing. Above grade, it's going to be our water-resistant air barrier systems, and then below grade, we're going to have true waterproofing membranes to protect the structural concrete. Lastly, we're protecting the membrane, but we still need to drain the excess water away. We don't want our membranes and our structures sitting in liquid water if they don't have to be. The more that water or our buildings are sitting in liquid water, the more likely or the more opportunity we're giving those membranes to fail. So our drainage systems are going to include drainage mats or drainage boards that will help move the water away from the structure down to the base of the structure, that will tie into French drains or other drainage systems that will move the water away. So all 3 of those are strategies we use for our water control system. Now, specific to below grade, there's a couple different options to install waterproofing protection. So the positive side systems, which I'm sure most people are familiar with, is installing the waterproofing membrane on the most exterior side of the structural component, or the wet side, the side that's going to be receiving water first. We can also waterproof on the negative side, or the dry side, or we can use integral waterproofing products where the waterproofing mechanism exists inside the concrete itself. But no matter which system we end up using on our project, all of them have some common characteristics. The main one being resistance to hydrostatic pressure. If your membrane is not resistant to hydrostatic pressure, then it is not a waterproofing membrane. It is by definition not a waterproofing membrane. Now, there are products out there that are resistant to water, but not under hydrostatic pressure, and those are categorized in a different group called damp proofing. There are certain situations where damp proofing is acceptable, in very dry climates with very dry soil where we're not anticipating any hydrostatic pressure or buildup of liquid water, but that is going to be very site specific, and always make sure you check code to see if it is appropriate for the location that you're building. These systems also have to be continuous. It does not matter how robust the system is, how expensive the system is. If we have damage to the membrane, or a penetration that's not treated correctly, or an open seam, because that's where the water is going to get in. It's going to find the weak points and force its way into the structure. So the membrane must be continuous. These also need to withstand job site pressures, or job site stress, environmental exposure, UV exposure. We try to get these waterproofing systems covered as quickly as possible to protect them from UV, but they still need to have some leniency because we know that doesn't always happen as soon as we'd like. Strong, flexible, tear resistant. If we can prevent job site damage, then that's less that we have to patch later. And every tear, every puncture needs to be sealed before we can pour the concrete, or in some sense, or some cases, backfill against the membrane. These are not maintenanceable systems. Once we pour the concrete or backfill, depending on the system we're using, it's very, very difficult to access these systems. If something goes wrong, then we're looking at remedial waterproofing, which can be very expensive, and it's not an ideal situation. So these systems have to withstand the entire life of the building and not degrade over time. How long are we building our buildings for? 50 years, 60 years, 100 years? These membranes need to be able to last a long time. And lastly, they need to be able to accommodate movement. Soil is going to move, concrete is going to crack, and as these buildings shift, we need to make sure that our waterproofing systems will hold and continue to protect the structure even after this movement has happened. And that doesn't necessarily happen with integral waterproofing, but we will get to that. Hydrostatic pressure, remember, is the #1 defining characteristic of a waterproofing system, is it must be able to withstand hydrostatic pressure, which is the constant force of water pressure below grade that is forced upon foundation walls. So water weighs about 60 pounds per cubic foot during heavy rains where the ground is saturated, or if we have a moving water table. There's all of those reasons why we could have liquid water forcing itself against our structure. And last week in Dallas, we had all that winter weather where we had many of the water mains that had busted. That created an unexpected amount of soil saturation, a lot of liquid water going into the ground that maybe wasn't anticipated. That's going to add to the hydrostatic pressure. And in this image here, we're only 1 story below grade. So yes, there is some pressure. Yes, several feet of water. We might get a couple 100 pounds. But think of our parking garages. There are parking garages in Dallas where I live. Didn't know if I mentioned that. I live in Dallas. That go 10 stories below grade. I think the deepest parking garage in the world, if I'm remembering correctly, is in China at 19 stories below grade. So if we have high water tables, saturated soil, all of this water stacked up against each other, several stories down, that can be thousands of pounds pressing against our foundation walls, and these membranes need to be able to withstand that. Even well-constructed foundation walls can suffer water damage. So yes, we need to protect our structures. Concrete is great, but we need to help it out just a little bit. All right, choosing a waterproofing system. In general, which waterproofing system do you need? The integral waterproofing that we discussed essentially will turn concrete into the water barrier. So normal concrete is very porous. It has a lot of holes in it, essentially. And by adding this crystalline admixture, it encourages more crystallization. So not only does the concrete cure, but then there's another chemical reaction that will fill in the pores that normally exist in in typical concrete. This is great, except when the concrete cracks. Small cracks, micro cracks, this crystalline material can actually help self-seal some of the concrete, but if we have a larger crack, larger than this mixture is able to create an adequate chemical reaction to build those crystals back together, then we just have a hole in our waterproofing system. So I don't see integral concrete or integral waterproofing typically on the commercial projects unless it's being used in combination with another system. Negative side waterproofing, so waterproofing the interior side of the wall, the dry side of the wall, is typically only used if we cannot access the positive side. So think existing construction, elevator pits potentially, or remedial waterproofing as well. So we have a positive side system, there's an issue, we have a leak, we can't access the positive side, so we can put negative side waterproofing to help fix that. One of the disadvantages of negative side waterproofing is that while it may keep liquid water from entering the occupied space, it doesn't actually protect the structure. Liquid water can still penetrate the structural component, the concrete, and not only are we concerned about liquid water, but also soil contaminants as well, especially sulfates, oil, salt. All of those things can erode the concrete very quickly and potentially corrode the structural steel as well. Negative side waterproofing also doesn't protect against freeze thaw, which down here in the south we're not so concerned about, but up north it can be a big concern where water will enter a small crack, it will freeze, it will make the small crack a bigger crack, and then the next cycle more water comes in, freezes, makes that crack an even bigger crack. So there are uses for negative side waterproofing, but most of what we do for new construction is going to be positive side. Now, positive side is the best option whenever possible, because not only does it keep liquid water out of the occupied space, but it protects the structure as well. And really that's our main objective, is to make the structure last as long as it possibly can. So both Blindside and traditional waterproofing fall under this positive side waterproofing category. Let me go on to the next. Here we go. So here's the next slide. It shows both versions The traditional waterproofing is in the lower right and the Blindside is on the left. And essentially the end result of Blindside and traditional waterproofing is the same. We're still waterproofing the most exterior side of the substrate. Also, if we look at the finished product, everything is in the same order. It's just the order of installation that is different. So with traditional waterproofing, we will over-excavate a site. Then we will pour the concrete walls, let the concrete walls cure, and then apply the waterproofing membrane to the structural concrete. In a Blindside application, we're going to only excavate the footprint of the structure. Then we will install a soil retention system, apply a drainage board or protection course against the soil retention system, then install the waterproofing membrane, and then pour the concrete directly against the waterproofing membrane. You may have heard Blindside referred to as pre-applied and traditional waterproofing as post-applied. Those are also different terms for it, but essentially the end result is the same. So why would we use a Blindside over a traditional? It is slightly more expensive and it is a little bit more work. Well, actually, Blindside waterproofing has been around for a very long time in various forms, since the early 1900s, due to the expansion of our urban environments. I see this all the time in cities where a surface parking lot is being turned into a 12-story office tower, maybe 5 to 8 floors of parking below grade, and on either side are existing buildings. Well, we cannot over-excavate or damage the existing buildings. The only opportunity we have to build is within those lot lines. But there are more than just urban environments where we can use Blindside waterproofing. Hill construction, so if we're constructing on a hill, it's not possible for us to over-excavate into the hill. We'll need to use a Blindside application. Or if we're building inside the water table or high groundwater, we don't want to over-excavate and then have to keep a larger area than necessary dry. We can excavate just the footprint of the site and then use pumps to make sure that only that area is free of water during construction. There may be other situations too where we don't want to disturb certain ecosystems, or if we're near a brownfield site and we don't want to disturb any more soil than necessary. Those are also situations where we may want to use a Blindside application over a traditional. And there are many different ways to select, or many different strategies in selecting your waterproofing system overall, and I won't go through all of them, but when we go through specifically traditional versus Blindside, the reason we run into most is just site access. Can we get to the positive side of the wall? Is it realistic and cost effective for us to get to the positive side of the wall in a traditional method? If it's not, then we need to default to a Blindside method. All right. Here we go. So like I said, things actually end up in the same place after a traditional installation or a Blindside installation. The drainage board or protection course is on the outside, then the waterproofing membrane, then the concrete. But the installation of these items essentially is opposite. So in Blindside, we put up the soil retention system first. Sometimes it's called supportive excavation. And that could be wood lagging, shotcrete. There's a bunch of different things we'll go through later. And that's going to be held in place by tiebacks to make sure that the soil stays out of the construction site. Then is the drainage board or protection course, then the waterproofing membrane, and then finally the poured structural concrete wall. There are many different types of soil retention systems, and I won't go through all of them. This is just a couple of them here listed: the wood lagging, sheet piling, soldier piling, or slurry and shotcrete. But the most important thing, no matter whatever system you use, is that the soil retention system is smooth and continuous. Another thing to remember about these soil retention systems is they are designed to be temporary. They are designed to hold up the drainage board and to hold up the waterproofing membrane until the concrete is poured. But once it is poured, the ultimate goal is that that those membranes bond with the concrete, and the retention system probably is going to degrade or shift over time. This picture here, I do want to note, you can see that the waterproofing membrane is going on the bottom below the slab and then going up the walls. This actually is a fairly typical application, because if we're protecting the vertical walls against hydrostatic pressure, then there's probably a lot of groundwater we need to anticipate, and we need to protect underslab as well. It doesn't always happen like that. There's a lot of different variations based on soil conditions and that sort of thing. But one term for this application is a bathtub. We are bathtubbing this site because we're waterproofing both the base and the horizontal, or excuse me, and the vertical. All right, so surface preparation of the soil retention system. Again, it must be smooth and continuous. All gaps in the soil retention need to be filled. If they're larger than 2 inches, they need to be filled, and that can be with plywood or concrete. Sometimes it can be foam, but I'm not a huge fan of foam. And the reason for that is as the concrete is poured, it's going to push out these more flexible membranes into the voids and create protrusions. So as the soil retention system degrades or shifts, then those protrusions become very vulnerable for what I'm trying to say, impact or damage. So we want to fill the voids. Drainage boards help a lot. So the smaller gaps, we don't have to fill in like every little space in between the plywood, because the drainage board is going to create that smooth surface most of the time. If you're using a slurry or a shotcrete, you must grind down any sharp points. Again, for that same reason, as the concrete is poured, it's going to push the membrane hard against the soil retention system. And if there are any sharp points, they can potentially puncture the membrane. And at that point, we don't know the membrane is punctured. We won't know there's an issue until we have water flowing into our building. So if you're using shotcrete or slurry, make sure it is as smooth as possible. Drainage systems actually act as 2 things. We want water to go down the drainage system as quickly as possible. We want to move that water away from our membrane and prevent any buildup of hydrostatic pressure. Now, these drainage boards are usually composite boards. They're made of a couple different materials, including a soil filter fabric that will keep all of the soil out of the drainage board so it doesn't clog. It has these this S-shape opportunity for the water to come down, so it's free flowing all the way to the base, and then it will tie into whatever the drainage system is around the foundation, whether that's a pump or French drain or any of that. There are different size drainage systems for different applications. If we're only going 1 story below grade, we're not going to need as much flow capacity as if we're going 3 or 4 stories below grade, because the opportunity for water to build up is greater the deeper that we go into the earth. Now, if you're building inside the water table, then your drainage mat actually isn't going to do much in terms of drainage. It might still protect the membrane against that shifting soil, and as the soil retention system degrades. But if we're sitting in the water table, we're still going to get that hydrostatic pressure. So we may use a different type of protection course, or if we're using a bentonite product, which we haven't talked about yet, but we will, bentonite products actually need hydration to work effectively. So we don't want to prevent water from getting to those types of systems because it's part of the system. But we'll talk about bentonite in detail a little later on. So the 3 different types of membranes that are typically used in blindside waterproofing are the sheet applied membranes, the fluid applied membranes, and the bentonite membranes. So sheet applied and fluid applied, or well, we'll start with sheet applied. Sheet applied are typically made out of some sort of bituminous material like a polymer modified asphalt, and then they're put with some sort of laminated plastic facer that will help with durability, like an HDPE, PVC maybe, a butyl rubber, TPO. Like there's so many different types of products out there, but that will help make them more durable. And depending on the manufacturer, they also have a lot of proprietary materials that are involved in these sheet materials as well, geotextiles, adhesives, and that sort of thing. Bentonite is a naturally occurring product. It is a clay that has the potential to swell up to 15 times its size as it absorbs water, as it is hydrated. And bentonite is actually an incredibly effective waterproofing product but it relies on compression and hydration. So as that bentonite absorbs water, it turns into this waterproofing gel. And as long as it remains under compression, then it will protect our structure from additional water because it will absorb all of the water. Unfortunately, bentonite is not a vapor-proof material on its own, and it's not a very structured material. So as it turns into a gel, it kind of loses its structure. So bentonite is usually going to be combined with a plastic facing or a lot in between a lot of layers of that geotextile. So as the bentonite expands, the geotextile fabric will hold it in place. And as the soil shifts, it will keep it together in order to keep our structures protected. Now, no matter which system we use, it is very important that the soil retention system is installed correctly. If it is not, it can cause issues and punctures on our membrane. The membrane must withstand the weight and pressure of construction. And when we talk about fasteners, we'll talk about how important that is, that the membrane stays upright as the concrete is poured. And then careful attention to the details during installation, because like I said, once the concrete is poured, we can't see the membrane anymore. We don't know there's an issue until we have moisture or water coming into our occupied space. So paying attention to penetrations, paying attention to tiebacks, making sure those are detailed correctly. Any sort of damage needs to be patched prior to the concrete being poured. All right, a little more on sheet waterproofing. There's two different ways to do it. Either a mechanical bond where a geotextile actually becomes physically embedded into the concrete to create a mechanical bond, or there are products out there that have a chemical adhesion, like an adhesive that will bond to the concrete. And they do require skilled labor to install, but I would argue that all blindside membranes require skilled labor. All waterproofing should require skilled labor. And proper detailing at the seams with sheet waterproofing membranes is very important because that's the weak part, is the overlap on the seam. And we'll go through seams in a minute. One of the benefits, though, is that it's a uniform thickness. We're not depending on the applicator to make sure that there's enough membrane there to do its job correctly. Lots of different options for sheet membrane. And we kind of already talked about this, where there's sheet membranes with chemical adhesion and sheet membranes with mechanical bonds where it's embedded into the concrete. They both ultimately perform the same function, is getting that sheet membrane fully adhered to the concrete, because remember, the soil retention wall is temporary. It's not going to do anything as it degrades over time. We really need that membrane fully adhered to the concrete in order to fully protect the concrete. And these are just two different ways of doing it. All right, sealing the seams. So like I said, the seams are the weak points of these sheet membranes. So we need to make sure that they are protected and sealed to keep water out. Now there's different ways of doing it. Some systems require a tape, so the seams are taped, and then that tape is rolled to create a really strong bond. Heat fusing is where we're essentially melting the two together. We're fusing them using heat to create one membrane. And then many of them also have self-sealing factory edges. So there's an adhesive on the factory edge during the overlap, and all of those seams need to be rolled. However, if you are building in the water table, then we're going to do seams a little bit differently. So heat fusing is acceptable if we're building in the water table because it is probably the best watertight seal. But if heat fusing isn't an option, we will reinforce the seams with a liquid membrane and then reinforcement fabric embedded into the liquid membrane. And that's going to be on 12 inches on either side of the seams. But if we're in the water table and these are the weak points, we need to do that work to ensure that no liquid water is going to move past this membrane. So in the water table, heat fusing and embedded fabric reinforcement are the two options. All right, seam transitions. So we've been talking a lot about the vertical plane. We mentioned how when we're in a bathtub, we're also doing the horizontal plane as well. And those seams can become very tricky when we're moving from vertical to horizontal. The way we deal with that is we just make the angle a little less steep so it flows a little bit easier. And we can use liquid components or tapes or flexible sheets just to make that angle a little bit easier and not to put too much pressure on the membrane. But we do need to reinforce that area because that's going to be another one of those weak points we have to watch out for. All right, fluid applied membrane. So this is a different type of doing blindside. I apologize that I don't have a picture for this one, but essentially with fluid applied membranes, we're hanging geotextile fabric or attaching it to the drainage board. And then we are spraying an emulsion, a spaltic emulsion on top of that geotextile to saturate it and to create a durable, seamless membrane. Now, this is a little more dependent on applicator ability because we need to make sure that the thickness is correct and that all of that fabric is saturated correctly. But the benefit of not having any seams also is a reason why many people choose this type of membrane. I had something else for this. Oh, yes, bonding. So the way that sheet membranes bond with that adhesion or the mechanical bond is completely different how the fluid applied membranes bond to the concrete. After the concrete is poured, it starts the curing process, and that concrete cure actually generates heat, enough heat that it will soften the surface of the emulsion liquid, so it will reliquefy in a sense and attach itself to the concrete. So that's how these fluid applied systems can argue that they are a fully adhered product because of that heat attachment. That's how that creates the bond. I'll be honest, I don't work a lot with these fluid applied membranes, so I'm sure you guys have a lot of questions. I have a lot of questions, but it seems like a really interesting system, and it's also considered a fully adhered system, which is the goal. The last category of the bentonite, I know we talked about this a little bit already. Bentonite membranes are not fully adhered systems because they're not going to bond to the concrete in any way. They're just going to exist outside the concrete under compression with consistent hydration. That's how they work. Bentonite is best used in areas where it has constant hydration, so either in the water table or very high water tables or climates where we can expect a lot of ground or soil saturation. What we don't want to do with our bentonite membranes is put it in applications where there are a lot of wet-dry cycles, because bentonite is most effective when it's fully hydrated. If we have a long dry spell, the clay starts to dry out, it starts to crack, it moves within its constraints, and then when we have another rain event, rehydrating, it takes some time for the bentonite clay to become rehydrated. And at that point, our structure is vulnerable as water can move through the clay until it's at its full capacity, until it's working at its most effective. Let's see. Yes, so it's also important for bentonite that it's not prematurely hydrated. So if you are expecting a bunch of rain in the next couple weeks and you don't have enough time to, or you're not ready to pour the concrete just yet, just hold off, because if the bentonite clay gets wet, it can start to swell before it's under that compression state, and we lose a lot of the strength in that system. Essentially, we just need to replace it with dry bentonite at that point. So we need to be very, very careful not to get these membranes wet before they're supposed to be wet. Just keep going on that. Fasteners. Okay, so fasteners are very important. Always follow the manufacturer's instructions. Do not skip on fasteners. We need to make sure that these membranes are going to remain vertical during the concrete pour, and the weight of the concrete is not going to pull the membrane down. That can create, wrinkles, which aren't great, but we can deal with them. Or if it pulls it even farther down, and we have huge sections of the wall that are unprotected, we'll have to take that concrete out, re-waterproof, re-pour, and it's very, very expensive to correct. So make sure the correct fasteners are being used, make sure they are sealed if they need to be sealed, the correct placement, And that will depend on the soil retention system. It will also depend on the type of membrane that you're using, how those fasteners need to be applied. Okay. Detailing penetration, so these are vertical penetrations, pipe penetrations, conduits. I think that is a tieback. And they're actually fairly easy to deal with. The hardest part about dealing with these types of membranes is catching all of the spots, that's all. Penetrations are easy to spot. We know we need to detail them. We can use a liquid membrane, or we can use a liquid membrane with or a mastic with a piece of the membrane, the sheet membrane on top of it. So those are two ways of dealing with these types of things. Tiebacks, two ways of dealing with tiebacks as well. We can completely cover it in a liquid membrane, which is the picture there on the right. Another option is we can build up a cover for the tieback using different materials. Then we will cover it in a liquid membrane, embed a reinforcement fabric into that liquid membrane, and then we can very smoothly place the waterproofing membrane over that whole section. Just two ways of doing it. And then after the membrane installation, I would argue this is the most important part, not the cleaning part. We do need to clean it, make sure it's dry, that it's not wet, so we get optimum bond. But the most important is to inspect the membrane immediately prior to the pour. And this is after the rebar is installed. Okay, because once the concrete is poured, if there's any defects or damage that we didn't catch, we're not going to know about it until we have an issue, and at that point it's very expensive. So take your time during these inspections or these observations. Make sure we patch every single piece or damage or defect. If it's small, fairly easy, 1/2 inch or less, we just paint over it with some liquid membrane or mastic. 1/2 inch to 1 inch, we're going to embed fabric into that liquid membrane just to give it a little bit more strength, a little more durability. Anything over 1 inch, it's a little cumbersome to repair, especially after the rebar has been installed, but it is very important that that 1 inch gap or 1 inch puncture doesn't end up causing thousands of dollars or millions of dollars later on. So if we have a puncture over 1 inch, making sure that we cover it in liquid membrane, overlap with a new sheet, and extend 6 inches on either side. Again, it will depend on your system, exactly what you're supposed to do, so always follow the manufacturer's installation guidelines. Always double check. Make sure everybody on the job is trained, not just the foreman. Make sure that every single person installing this membrane has gone through training with this specific system, because we need to make sure that it's done correctly the first time. All right, so far we've talked mostly about the vertical waterproofing. Now we're also going to talk about the underslab, so that water protection, vapor protection below the slab. Not only do we want to protect against liquid water, because without it, remember that wicking ability of concrete to suck up water through capillary action and surface tension and all that fun stuff. But we also need to protect our structure against water vapor. And we're not going to go too far into water vapor in this presentation, but we want to prevent moisture and mildew in those below grade spaces. And we need to protect the flooring and all the pretty stuff inside as well, because water vapor is also known to debond adhesives, especially the water-based adhesives. If we have any wood flooring, the wood flooring will absorb that moisture as well and cause the floors to buckle. So many different reasons why we not only want to protect against liquid water, but also the water vapor. There's an image, that image of the bathtub installation again. Horizontal soil retention systems, and that title is probably a little bit misleading. We're not really retaining soil in the same way that we're retaining soil out of the vertical excavation. Many times we'll see just compacted soil, and that's an acceptable substrate before we put down the waterproofing membrane or the gravel or the drainage or whatever we need to do. But the key factor of the vertical soil retention system, it has to be smooth, it has to be continuous, also applies for the horizontal surface as well. So often you might see a matte slab or mud slab or clean slab. There's so many different words for it, but they all mean the same thing, where we put down a sacrificial layer of concrete that doesn't have any reinforcement. It's not meant to be structural. It's just meant to provide a clean, flat, dry substrate that people can walk on. There's no mud. We're not worried about mud. And that we can lay this waterproofing membrane down and be confident that we're not going to get any punctures or anything like that. At this point, you could install the rebar, pour the structural slab, and keep on going. But there are some instances where if we have a lot of people walking around on site, we want to make sure that this membrane is as protected as it possibly can be. You might also see a protection slab on top of the waterproofing membrane as well. And the protection slab is just a couple inches on top of the membrane that will protect it from the job site of abuse, so we don't have to worry about going in and repairing punctures and that sort of thing, because rebar is pretty heavy. If you drop a piece of rebar, likely it's going to puncture your waterproofing membrane, and that will also need to be patched. You might see some of these on your projects. You might not see any of them other than compacted soil on your projects. Excuse me. But I think the biggest indicator of what you're going to use here is what your risk factor is. So if this is for a parking garage or something, or where it's not really occupied space, but we still want to keep water out, then you might not need all this, because the risk of a puncture or something like that is not going to have a huge effect on the rest of the structure. However, if this is a basement for a museum that they're using for archival space, then we want to make sure that the entire below grade section is as sealed as it possibly can. Yes, it's going to be a little more expensive, but the risk of the waterproofing failing is going to create a lot more damage and expense than on a parking garage situation. So that's kind of how I guide people to decide what level of robustness and what they're willing to spend on these types of systems. What is the risk if the waterproofing fails, and will you be able to live with that? Sorry, that was a little tangent there. So like with vertical waterproofing, we also have to detail all of the horizontal penetrations as well. So here is a cluster of pipes. We used a liquid membrane just to fill in all the gaps and cracks as best we could around those pipes. It's not an ideal situation that they're so close together. We can't guarantee that the pipe in the very middle of the cluster is perfect. But in this example, we did the best that we could do. Here's another example. This is a single pipe, which is more effective and lower risk if we can detail every single penetration rather than doing them in clusters. And this is where we have an embedded reinforcement fabric into a liquid membrane. So just a different way of detailing it with a little bit more protection, adding that reinforced fabric. All right, just a couple of project examples of where Blindside was necessary. This project was up in Ontario, and you can see in the picture this huge piece of rock that we're not able to excavate. We don't want to excavate. That would cause too much money and too much environmental damage. So the only way to waterproof this structure would be to use a Blindside system, and it worked very effectively. Here it's not a great picture of this property, but this project is in Arizona with absolutely zero property lines, extremely limited site access. And so Blindside was the only necessary solution because we weren't able to access the positive, what would have been the positive sides of the wall in a traditional waterproofing sense. All right, and then just a couple best practices, some recommendations from my experience is follow manufacturer's instructions. If they're going to recommend certain accessories, then use those accessories. Always single source whenever you can, because these membranes come as a system. They're intended to work as a system. And if you use all of the accessories from one manufacturer for that one system, we're cutting down on potential compatibility issues. And you're very certain that you're not jeopardizing your warranty in any way. So if you can, single source all of your accessory products as recommended by the manufacturer. Pre-installation meetings. Pre-installation meetings are the best, and I know they can be a little difficult to get everyone in the same room together, but this is when we're going to talk through all of the issues, and it's so much easier to do that sitting around a table than it is standing in the middle of a job site trying to figure it out then. So what details need to be reinforced? How are we going to do the terminations? How are we going to detail the tie-in or the tiebacks? How are we going to tie it into the above grade air barrier system? All of these tricky parts that need to be discussed ahead of time with the manufacturer, the installer, the general contractor, everybody who's going to potentially touch this membrane needs to be involved in the pre-installation meeting. And then, I might be a little biased on this one, but please involve your manufacturer as much as you can. We know these systems really well. We know what works with our products. We know which situations different products will excel in and when you might need a more robust system. So bring us in at all stages of the project in design. We would like to be part of that pre-installation meeting. We want to be available for job site observations to ensure that it's being installed correctly. So please don't hesitate to reach out. The manufacturer really wants to be involved. Okay, and that is all I have. I hope you guys learned something. I know I talked pretty quickly, but if you have any questions at this point that we haven't addressed, Roger has also, he has quite a few more field experience years than I do, so I think Roger is going to help me answer some of these questions. I think we're good to go.
Thank you, Conleigh. Excellent job. Wonderful presentation. One of the great things about it, as I was looking at the chat area and the Q&A, is questions were coming up that you answered as we went through the presentation. There was questions about tiebacks and questions about penetrations and pinning that you hit later. So I thought that was excellent that we were able to get those. I'm going to reach out to Stacy Bogdan now to join us also. Stacy has experience, considerably experience in blindside waterproofing. A couple of questions that came up, and we tried to get to all of them. You guys had some very good questions. One was kind of interesting. Will bentonite, and I'm going to paraphrase a little bit, will bentonite lose its integrity if subject to wet-dry cycling? And I think you covered that a little bit in your presentation. My answer as I was writing it down and thinking about it was, depends on who you ask, because you ask bentonite manufacturers, they're going to say no. But yes, there is considerable concern about cycling with bentonite as it losing its integrity. So it is something to consider. Another one that popped up was, are wood shoring systems typically left in place to rot? And the simple answer to that question is typically yes. However, most wood shoring is now constructed of what do I want to say, treated lumber, and that treated lumber has very significant expected lifetime in those situations. But yeah, that raises the importance of being able to bond to the concrete. We want the waterproofing bonded to the concrete structure, not as much and strongly as to the wood shoring system, so that if the wood shoring system goes away, we are still well bonded to the concrete. Stacy, if you're here and you can hear this, since I'm in Southern California and we don't deal much with insulation, there were a couple of questions on insulation incorporated both underslab and vertically. Can you talk about that for a couple minutes?
Yes, I thought I answered it in the Q&A, so I'm not sure who saw my answer or not, but so typically for the wall, it really depends on what the engineer would like. But and when it comes to the manufacturer, well, wrmeadows, we don't really care if it's soil retention, then insulation, drainage board, waterproofing, or it could be soil retention, drainage, insulation, waterproofing. So what I'm trying to get at is that as long as the waterproofing membrane is has contact with the poured concrete wall or shotcrete wall, then that's all. And it's a smooth sound substrate, then that's what we require. So if you do have insulation, and then just say our pre-con membrane, the insulation has to be butted together and smooth. So when you press on it, just like concrete, that it doesn't move too much, right? You want to create a smooth sound substrate. So as long as the waterproofing membrane is is at where the concrete can contact it and bond to it, then it would be fine.
Okay, yeah, thank you. I appreciate that. Like you said,
And sorry, and underslab's the same thing. So if you're a mud slab, then you'd put your insulation, and then you'd put your waterproofing course, and then pour your protection slab or structural slab on top of it. So, and again, you want the insulation to be butted together. A lot of times I do recommend that they tape it together so that it creates sound substrate for the waterproofing membrane to be placed on. Is that clear as mud?
nope, that's good. A couple of questions just came in, and there were some questions in the Q&A that I think we should address outside of this forum. They're very detailed. What is the repair method if the blindside system develops a leak after the concrete is poured or is damaged during the pour? And generally speaking, and Conleigh mentioned this, that the importance of blindside in getting it right is that we have no access. So if something were to happen, generally speaking, the accepted method of repair is to inject with a hydrophilic grout, potentially hydrophilic urethane, foams, different things, but generally speaking, that is the accepted method. You could also, we talked about blindside, or not blindside, negative side waterproofing repair. You could integrate that into the system. My concern, and I'm sure, and I'm sorry, Conleigh, I was answering so many questions, I didn't hear every word that you said. But,
That's all right.
but my concern with any negative system is that you are allowing water into the wall, into the structure. So sometimes these injection systems that go through the wall and expand on the outside of the wall are better suited for that. I saw a question about detailing for sharp angles. In other words, angles that are less than 90 degree. And I've never encountered it. I don't know, Stacy, if you have. I don't think that it technically or differs from general detailing of corners, except that it's just going to be more difficult. It may be a situation in that where we reduce the angle by filling it with grout to soften that corner, so that instead of a sharp, let's say 45-degree corner, we build that out and create a cant in there so we can turn the corner more easily.
Yeah, I agree. Sorry, and was this from the wall to the mud slab, or are we talking about a inside corner vertically? I wonder.
I don't know that. I don't know that it said that.
Okay, so because if it's a vertical wall, then you have your drainage plane or your mel drain to create on the inside corner to make a cant for your waterproofing membrane typically. But yeah, I agree with you, Roger, that a cant is always great from if you're going from the horizontal vertical to the horizontal. And that typically made with, like you said, a grout or a drainage plane, or you know, pieces of, I've seen wood, but yes, a cant is good.
Okay. I'm trying to get to a few more, and my scrolling just stopped.
Yeah, just hit on the Q. That happened to me too.
Let's see.
Oh goodness, I just opened the Q&A and quite a few questions just flooded in.
Yeah.
Yeah.
We'll just pick a couple, and then we'll, for anybody who submitted a question that we're not going to get to verbally here, we will be following up with you with an email to make sure that you get the information that you need.
I think there was one,
Well, there's one here real quick that I'll address. Can you pre-apply a negative system to precast walls if used below grade parking structures? I don't know that I would.
I'm trying to think of how that would work. I've never run into that sort of thing before.
So, okay, so precast walls, you could, yeah, I guess in theory you could. The question would be, you would still have to detail. So you would take a precast panel, put it in place with your, for in our instance, let's say Semcoat Flex ST type system, or even a crystalline system that would waterproof the wall from that aspect, and then place the wall. The problem would be you still have to detail all of the joints between the precast walls, and also the attachment to the footing that you're setting the precast wall on. At least that's how I interpret it. So,
there's another one here. How best to waterproof if existing foundation wall is in place and new wall above will be, I guess, placed directly above the existing wall, a jog and waterproofing? Well, if I understand correctly, so if you have there's many projects that you have two applications, a blindside situation, and I call it open cut or traditional. And so we have many, and all manufacturers have many details how to transition from a blindside membrane into an open cut membrane. Because a lot of times, many manufacturers, you cannot use the same membrane. So as long as you overlap these membranes with liquids or sheets and then put a protection board, then but yeah, basically I would get in touch with your manufacturer of the membrane and find what detail is on how to transition from a blindside to an open cut transitional.
okay, another one that came in terms of negative waterproofing. Is there a roller applied liquid membrane for interior side application, negative side application? Recognize the limits of not protecting the wall itself. The concern with using liquid membranes, whether they be epoxy or polymer, polyurethane type based membranes on the negative side, is the bond strength of the membrane to the concrete. The liquid vapor and liquid drive and vapor drive coming through the wall generally will debond that material, as opposed to the cementitious flexible cementitious materials, because they tend to be less vapor permeable. And generally what happens is you end up with blisters on the inside of the wall that are filled with liquid. So there's generally not recommended to use polymer type products in those situations.
Another quick one, are there expansion joint systems compatible with blindside waterproofing applications? Definitely. There's many. I'm up in Canada, and mechanical joint systems are definitely needed depending on the situations. So please, again, get in touch with your local rep, and we can definitely talk about how to incorporate expansion mechanical joint systems into our systems.
All right, we are past the hour, and there are so many questions that we just simply will not get to all of them. We appreciate your attendance. We appreciate the questions. A couple things that I do want to address. There have been several requests for the presentation. Please contact us at info@wrmeadows.com. Give us your contact information. We will certainly provide that. I believe, if I'm not incorrect, we're going to post this on YouTube. I think we've been doing that in the past. So this presentation will be up on YouTube pretty quickly. There was a question about how can I get in touch with my local representative. That question actually, I believe, came out of Georgia, but in general, send us a note at info@wrmeadows.com, and we will be getting back to you. And lastly, certificates will be sent out once we get to process all the attendees. I want to say thank you very much. We actually had over 500 people in attendance today, which is a phenomenal thing for us. We will be getting those certificates out to those of you via the email that you sent us. Please be patient. That's a lot of registrations to process. So I think with that, I'll say thank you and good afternoon. Conleigh, if you've got anything else to add in closing, please go ahead.
No, I'm good. Well, thank you so much for joining us, and we'll try to get to all your questions via email. Have a great day, guys.
Thanks, everybody.